talking about openBIM and digital twinning and case studies. This session will be sort of an introduction to the concept of digital twins, and how they, in an ecosystem of a digital twin, we talk about system of systems and stuff like that. So all good stuff. I'd like to start by introducing our first speaker, who's from the research team lead for the Carleton Immersive Media Studio at the University of Carleton, the Sims Lab, and also research lead for DBNCR, so the Digital Built National Capital Region, which is an affiliate to buildingSMART Canada. Please help me welcome Nicolas Arellano. Thank you.
Can you hear me well?
Yep.
Okay. Okay. Hi, everyone. So, Eric, thank you for the presentation. My name is Nicolas Arellano. I am an architect from Universidad Católica of Chile, and also a PhD student at the School of Architecture and Urbanism at Carleton University. And as he was saying, I am with Sims, a research team lead, and also the director of research at DBNCR Group. And today I will be talking about my own research, which is de-black boxing BIM. De-black boxing, I mean taking BIM models outside of proprietary software and close file formats. A black box is a system that can be understood only in terms of its inputs and outputs, which process is not accessible. It's opaque and is not even visible to users. So I will be showing how we are attempting to do this through a project that we have been developing at the Sims Lab, which is the digital twin of Carleton University campus. So at Sims, we started building this project back in 2013 as an asset information model, which could be defined as a multi-scale BIM. This project was initially founded by Autodesk Research, Carleton University, and also the Natural Science and Engineering Research Council of Canada, which is NSERC. For most part of the project, we have been using multiple proprietary formats, Revit and Dynamo for the federated model, Unreal Engine, Twinmotion, and 3D Max for immersive virtual experiences and rendering and visualization, and also InfraWorks for the urban scale. We have created a federated model that mirrors an intra-urban area of 62 hectares with more than 50 buildings and buildings that are BIM models also. This includes all of the buildings on campus, its faculty, the labs, the residences, the library, theater, athletics, among many others. We have also modeled all of the exterior zones and landscaping, including like the trees, the greenery, all the roads, signage, site elements, and much more. We have also modeled infrastructure services such as electrical, water, and gas networks. Here we can see, for example, all of the lighting fixtures on campus. And because this is BIM, each of those instances contain a link to the metadata, aesthetic metadata, and also dynamic metadata if we have. We have used different tools for reality capture, such as 3D scanning, photographs, photogrammetry, and also LiDAR. This point cloud that we're seeing right now, it's a point cloud of the LRT corridor that crosses the campus, so the train that they are building, the train online. We have scanned and modeled this area for the Carleton Facility Management and Planning Department. Because of the weather of Ottawa, we have 5 kilometers of underground tunnels. It's very particular of this university. And we have also scanned, 3D scanned at maximum resolution. We took over 300 scans, and then we have been modeling from point cloud to BIM to a very high level of detail. In 2019, we got an NSERC strategic partnership grant for which we have been collaborating for 2 years with researchers from System Computer Engineering and Architectural Conservation and Sustainability departments at Carleton. More than 30 students from different disciplines have contributed to make this possible. The Carleton Digital Campus is and will always be, hopefully, a dynamic work-in-progress model. As the campus continues to evolve, we will continue to integrate its new parts. This federated model works as a system of systems, as Eric was mentioning. So every time we model or acquire a new building or asset, we can just plug it into the system. Carleton asks contractors of new buildings to provide BIM models that can be easily plugged into the federated model. We have received a few of those BIM models as built BIM models, but everything else has been modeled from scratch from Carleton students at the SIMS using different data sources. At SIMS, we have been using programming tools and also visual programming tools such as Dynamo to automate some of these processes. For example, as I was saying, the integration of diverse data sources into the federated model. Data sources as diverse as CAD drawings, 3D models, data spreadsheets, among others. To increase efficiency of facility management and operations, we have been using algorithms to visualize complex data sets in real time. For example, here we can see a script that we have used to simulate and visualize parking availability on campus. This one is a simulation for building occupancy that we did with the Insert Partnership grant. This one is in order to operate buildings accordingly to their actual use. So imagine HVAC system that were able to be controlled depending on each room occupancy rate. With these techniques, we have linked dynamic data, such as energy consumption sensors, to understand building performance and manage their energy use accordingly. We have used Ladybug Honeybee to do sunlight analysis. With this script that you see here, it is possible to simulate the impact of new buildings on daylight condition in existing buildings on campus. This way, buildings can be designed mitigating the negative impacts they will generate over existing buildings. In this integration of dynamic data that has transformed this federated model into a digital twin. This is one of the most well-developed digital twins of university campus in Canada, and it was recognized by Building Transformation in 2020 with the CAMBIM Academic Innovation Award. Finally, we have used game engines, for example, Unreal and Twinmotion, to support university outreach activities, such as virtual experiences for students. We have created a series of 360 virtual tours that hosted thousands of students that couldn't attend campus because of the real campus, the physical space, because of the pandemic. It took years of work, or it has been taking years of work to build this complex and beautiful digital campus. And we have realized that we don't want all of this effort to just, that we have put on this model since 2013 to be archived in our service. The Carleton University Digital Twin should serve its community for many more years to come. So its students, staff, facility managers, planners, researchers, and more can benefit for this model and take advantage of the insights it can offer. However, if all of this is trapped in a black box, that will not be possible. What this project needs is to be safeguarded by long-term interoperability data standards, or openBIM. And we are here today gathered to talk about openBIM. So let's talk about that. This is exactly what the digital campus requires in order to be accessible to the community. But what does openBIM even mean? buildingSMART defines, states that openBIM extends the benefits of BIM by improving its accessibility, usability, sustainability of the digital data in the building industry, and also it is a vendor-neutral, collaborative process that facilitates interoperability to benefit the project throughout their entire life cycle. openBIM ensures openness of assets and processes, collaboration between stakeholders, and also flexibility of choice of technology. I agree with all of this definition of openBIM 100%. However, at the end of the day, openBIM sounds a lot like regular BIM. Why? Because all of these concepts that describe openBIM are also describing what was BIM designed originally for. The only thing, the one thing that we tend to call BIM is what we should be calling closed BIM, naturally. Because BIM was originally intended to be a collaborative approach to lifecycle management. BIM is about connecting people, processes, and data, but we cannot do if BIM is trapped in a black box. So far, proprietary software and closed file formats have been great for the building Carleton Digital Campus. And we really like these proprietary tools, and we are pretty good at using them. We have been using it for many years at SIMS, and I even have been teaching them at Algonquin College for the last 5 years. We have achieved so much using these tools, but unfortunately, they have a limitation. it is really hard for us to achieve openBIM with them. We believe there is still so much the Carleton digital twin can offer with openBIM, but with cloud-BIM, we won't be able to achieve that. When we use proprietary format, we are without that trapped in a black box for the following reasons. One, every user will need to have access to the software to participate. The software that we have been using are very AEC, so architecture, engineering, and construction and operation specific, with a high learning curve. Licenses are expensive and cannot be afforded, but most of the people or most of the community we are aiming to share this model with. Also, tools are complex, and the software that we are using gets larger and heavier with each release. And often, tools are added that whether you want them or not, or whether you need them or not. Also, these tools do not always meet our current needs, and there is nothing we can do about it. They are not very customizable, at least for what we want, and they usually come as is, and you cannot improve them. So you just have to keep waiting until the next release, and I hope it includes the improvement you need. Proprietary formats are not great for interoperability either, which make it hard to collaborate with non-AEC professionals. And even within the AEC world, or the AEC industry, we spend a lot of time transforming from format to format. Finally, the data loss. Because in projects that have like a long life cycle, we move from one version of software to the next one. And because the upgrading processes are also black boxes, we have no idea if we are losing data in the process. To truly take advantage of this digital twin, we need to explore its full potential. To do that, we need to present this model to the Carleton community and make it open to whoever wants to enjoy it. And to address this, we require a new toolbox, one that is centered in open formats, transparency, and flexibility. In the last couple of years, the open source community for the AECO industry has grown in accelerated pace. OSARC, for example, is an online community that promotes that the building environment or the built environment can be designed, constructed, operated, and recycled with free libre and open source software. This is a new reality for architects that makes BIM tools more accessible. And these tools are not only for professional coders. I, for example, am an architect, and I started coding just a few years ago. And I'm surprised of how much I am able to achieve or to do with these amazing free and open source packages that exist out there. There are several solutions available, and by combining some of them, the possibilities are just endless. At Sims, we are exploring, or we are working on a bespoke web-based open source platform. We want it to be bespoke because we want it to be reliable, so we know exactly what it does. We want it to be lightweight, bespoke because we want it to be lightweight, so it doesn't contain features that we will not need. And finally, we want it to be flexible to fit our custom needs. Then we want it to be web-based because we want it to be accessible to the Carleton community. No software will be required to look at our models, and any device with internet connection or with a modern browser will be able to host the models. We want it to be community-driven. This way, there will be more eyeballs to give feedbacks and say something about any issue that the platform will have. Web-based platform utilize online libraries, which are pre-programmed features that we can incorporate if we need them. Finally, we want it to be open source because we want to be able to repair it, improve it, and debug it if we need. The Free Software Foundation refers to free as free speech, and they define the 4 freedoms that the user must have when using software. The 4 freedoms are the freedom to run programs for any purpose, freedom to study how the program works and change it, the freedom to redistribute copies so other users can also enjoy them, and the freedom to distribute copies of modified versions. And this is their definition, but we also want it free as free beer, basically. So meaning that there will be no expensive licenses required. Finally, we want it to be transparent and to provide a better support for open data standards and open file formats such as IFC. The ISO 19650 defines open data as data that is available or visible to others, and that can be freely used, reused, republished, and redistributed by anyone. Our bespoke web-based open source platform prototype is based on JavaScript, HTML, and CSS that are the languages of all modern web browsers. And so far it uses Mapbox GLJS for GIS and mapping, 3JS for the 3D graphics, IFCJS, which is a really amazing library for working with BIM on the browser, and MongoDB for databases. These are just the ones that we have been using, but we can use so many more. Let me just show you a quick demo of the platform. So far, this prototype enables users to log in so they can customize their experience and save, for example, their favorite places into our database. It also allows users to easily navigate anywhere in Canada. We have organized Sims assets by places and objects. And there, in those places, we can visualize geolocated IFC models. That's the one that I'm showing right now. Sometimes there are not models, but we have a place. And also, users can also customize and add their own places. So we have added some features, so you can just go create a region that will contain the 3D objects, okay? So here, for example, I just created like a region. I upload it, and then I go and to create this 3D object. You can put it there, rotate it if you want, and then upload IFCs or 3D models or any data that you want. We have also incorporated some open data coming from online libraries such as OpenStreetMap with all of the LOD buildings. Also from Open Ottawa, like the bus stops in Ottawa with all of its information. And also you can customize if you have a specific use. For example, you can have like a traffic mode to your map, or even seeing a satellite image, a regular map mode, or our dark mode that is our default for now. So let me take you back to the Carleton model. Here we have been able to upload more than 4 gigabytes of data and more than 50 unique IFCs into the context. So you can see, this is a lot of data, and for the browser, it's not a big problem. It loads everything on the place, right in the map, and you can see and interact with them pretty smoothly. Here you can see the athletics, the residences, also the Faculty of Engineering Design, and all of the public buildings, the library, everything. Or we have also some little buildings like the Child Care Center with its cute play structures there. We have also the iconic and tall downtown tower with its more than 20 stories. And also we have complex buildings such as the architectural building or building 22. We have incorporated some BIM features from IFCJS. For example, we can filter by categories, or we can cut clipping planes to see the interior of our buildings. So here we can see that we have like all of the furniture. And if we go to, for example, I don't know, the main warehouse, you can see special equipment. And this is, and this can just keep adding. And now I'm going to take you to where the Sims Lab is in the Visim building. And I'm going to show you a few other features that we have been adding. For example, changing the perspective to an orthographic perspective. We can cut again to go to the 4th floor where the Sims Lab is located. And here you can see where we normally meet. Here are all of the furniture and digital assets that we have at Sims. And we can start like doing things, for example, taking measures right there on the 3D model, or using this communication feature to leave 3D message on top of the digital assets. So we can use this as a communicating tool too. Finally, because this is BIM, we can access to all of the metadata. Right now I have just a few properties and attributes, but basically we can add, fetch any information that is embedded in those federated models. So yeah, that's what we have so far. And this has been just a few months of developing this. There are not professional coders there. It's just like a group of people that are really into BIM and into openBIM. So this is what we have been able to do with these tools. Yeah. So that's has been our experience of trying to get multiple Sims BIM models out of the black box. And so far it's been great. I really recommend it. and it hasn't been that hard. There are a lot of resources and online communities at your disposition. So we really encourage you and recommend you to at least try these open tools from your own projects. Get your BIM out of the black box too. Tomorrow we will continue to talk about this in my colleague's presentation about Imagine Canada Digital Twin, where we want to take this prototype and scale it to experience this at the Canadian scale. And we want to do a prototype that is, again, open, transparent, and flexible. So anyone can participate, no matter their background or their budget. So yeah, please come and join us. Thank you so much for listening, and thank buildingSMART for the opportunity of sharing our work and thoughts.
Thank you. Thank you very much, Nicolas. Very inspirational, and I'm a bit jealous. I'd like to, as a research hat, to get that far. And it was at a morgue in the architecture building. I knew architecture was pretty rough, but I didn't know that they needed a morgue. All right, our next presenter. So to continue, and I love this perspective on fully open source, fully transparent. I think it's something we can really strive to. And so now we're going to get a perspective from Esri, from Marc Goldman, who's Director of Architecture, Engineering, and Construction Industry Solutions, who's going to come and give us some his experience with digital twins and everything. So thank you.
Thank you, Eric. Nicolas, that's a hard act to follow. That's some brilliant digital twinning you're doing there. Thank you. So I'm Marc Goldman. I'm the Director of AEC Industry Solutions at Esri. I've been involved in the technologies related to the AEC space, almost going back as old as that photo there. That's a picture of Ivan Sutherland using one of the original, perhaps the first CAD applications called Sketchpad, where you can see he's on screen using a stylus to actually design a chair in this case. I did not get involved in CAD this far back. I think I was born about 6 years after that. I've been involved in technologies related to the built world, going back actually even earlier than this image here. That's a version of, I think, AutoCAD 2000. I got around into CAD back in the mid-90s. Worked at Autodesk twice in my career, worked at Hexagon, I'm working at Esri now as a storyteller, finding out about amazing projects that our customers are using. This was one of the earliest versions of Revit at Autodesk, and this here is an image of a new solution from Esri called ArcGIS GeoBIM, where we're bringing together the BIM and the GIS in a single solution. So just a few examples of some of the things that I've worked on, that I've experienced, just to lay a little bit of context. At Esri, I think the first thing that people think about is we're a mapping company, and maps immediately convey 2D. We're so much more than that, and quite frankly, being in the CAD space and the BIM space, I didn't even realize the breadth of functionalities and capabilities that GIS delivered to AEC professionals. I mean, these are just a few of the things that we're doing that pertain to the work that AEC professionals do. Over the last 7, 8, maybe 10 years, Esri has made a big investment in BIM, in being able to read, write, consume, analyze, and deal with BIM data. 2017 was a real watershed moment when we stopped competing with the major CAD and BIM players, actually formed an alliance partnership with Autodesk, started bringing in Revit files directly, Civil 3D models directly, DWG, consuming them, adding BIM data to our geodatabase, most recently bringing in IFC, starting out with 2x3 and now 4.x. We're staying up with the latest versions that are available from the Open Design Alliance. As soon as 4.3 is fully certified, we'll have that available. We already have developers working on that, and you can see the mention of ArcGIS GeoBIM as well as our most recent solution. The connections between our solutions and specifically Autodesk, where we have our strongest relationship, a number of connectors that either Autodesk has written with us or that we've worked on with Autodesk to create the product called GeoBIM. We've really come to recognize the need to bring these two worlds together. We alone can't be a best BIM solution and the best GIS solution. Instead, we'll work with the players who are the leaders. Autodesk currently is our, the lead horse that we're working with, but we also do consume and work with Bentley data and Nemetschek files and various other sources, and certainly IFC, as I mentioned. There's a couple of products. I don't want this to be a product pitch, but I know that most AEC enthusiasts, users, architects, engineers, and contractors are not familiar with Esri solutions. So just a quick plug for our sort of hero product, ArcGIS Pro, a desktop solution that connects to all of the online content that you might need to consume, whether it's BIM or maps or temperature and weather data or demographics. ArcGIS Pro is our premier product, and then ArcGIS GeoBIM is this connector between the Esri clouds and currently the Autodesk clouds to bring BIM and GIS together. So why are we putting all this energy into BIM? Why are we making sure that we can read and consume and analyze not just the geometry, but all of the analytics, all the data, all the non-geometric information in BIM and CAD data? Well, it's because AEC projects are spatial. You might think they're special, they might be special, but they're spatial, and you just can't get around that fact. Projects exist at a location. Orientation, weather conditions, traffic flows need to be considered. Context is critical in the design world. And AEC professionals integrate massive amounts of data, and that data needs to be connected, and data serves as a connector. There really isn't a better solution that I know of than GIS for bringing in the many types of information that need to be considered before you put that first line, wall, door, window, center line of roads on screen. And I've found through many examples that the data that is now able to be connected between typical AEC work and GIS work, that data connects people, and that's enabling digital transformations. I've asked on numerous occasions in audiences like this, who as an AEC leader is in the midst of a digital transformation, not just digitizing processes, not just delivering digital files, but actually transforming your business. And if you're in the AEC world and you are not in the midst of transforming the way you work, you're going to be left behind. And I don't think anyone here is in that camp. You've come to an interoperability buildingSMART meeting for 3 days because you're in the midst of digital transformation. And these digital transformations are critical to deliver the information that clients are demanding. Digital transformation is critical for AEC project delivery, digital deliverables beyond just PDFs, beyond just 3D static models, but information that can be analyzed, leading to better insights, is simply the way of the world today. So I think when most people think about GIS, environmental management comes to mind. Means and methods of saving water, using less energy, less materials, helping our world be a little healthier for a longer time. And we have many, many examples of that. This is one that actually brings together GIS and BIM. This was, I believe it's pronounced Batsui Port in Taiwan, where during lockdown, our solution engineers in the US worked with professionals overseas to map out and process drone imagery and produce a very detailed sitemap, and then bring into that their BIM content so that the owners of the Port Authority, could understand the new buildings that were being proposed, how they would relate to 50-year, 100-year, and 500-year flood projections. So in this case, the building itself is raised off of the piers so that as flood is likely to happen, the buildings themselves won't necessarily be damaged. But it's also, I think, worth knowing, and I've seen through many examples, actually here, some that I didn't expect to see, that design and engineering workflows are significantly improved. The process of designing, planning, engineering your work, the deliverables that come out of that effort are greatly improved through GIS. When location information is considered, the outputs of the work of design and engineering is improved. And numerous examples of that as well. I believe that we've got some folks here from Aegis in France, maybe not in the room today, but certainly here at buildingSMART. This is a project that they worked on where, using GIS information to understand the context of the city of Paris, where were certain metro stations being used, where were population centers existing, bringing in the BIM information into the models so that you could produce a public site so that all the stakeholders, from the individuals who need to use a train station, to the planners who need to understand what the impact might be of a new train station, to the engineers themselves, understanding what the underground environment will be of the station in its environment, all brought together into a single solution to help the process of design and engineering. But where I've kind of been surprised is how powerful GIS serves construction management workflows. how it actually reduces cost and time risks, how it improves safety and creates a better project, a better environment, and numerous projects here. So the first one is from a US-based firm called HNTB, who have a 100-year history working on bridges. I described this as GIS and multi-BIM. Their project did not actually use, I don't believe, IFC, but instead Revit files, DGN files, various other formats to replace a 70-year-old bridge in Norwalk, Connecticut. So in this example, you can see on the itself little blue sensors, and we'll come back to those in a second. This bridge is made up of, like I said, multiple BIM environments brought into GIS and then delivered out in this ArcGIS GeoBIM solution I mentioned earlier. So all the capabilities you'd expect of a CAD or a BIM-like viewer, the ability to slice and dice and understand context. Here slicing through the lift station above this 70-year-old bridge, sensors placed in the environment, IoT sensors that feed back into the GIS so that as construction is occurring right next door, you're able to understand what the seismic situation is as you're doing pile driving, or as that lift bridge, the machinery is operating, is that creating an unsafe environment of higher temperatures than is allowable. So here, GIS, CAD, and BIM from various formats brought together to improve the process of construction management. So understanding, in this case, you can see temperature rising, staying pretty steady, but also I believe if this plays through, you'd actually see the seismic conditions as the pile driving is occurring. Another example, in this case, openBIM. So a Canadian-based firm, Pomerleau, who's upstairs right next to us at our booth, gaining insights from construction planning, bringing IFC data, proprietary data into a GIS environment. So here we've got a high-rise condominium, IoT sensors placed in the building, capturing in real time, actually IoT sensors in the concrete, so that in real time, understanding the curing conditions of the concrete as it's being poured, so that you know when it is appropriate and safe to move on in your construction process. So in real time, seeing the temperature going down of the concrete as it's curing. Sensors showing the dust conditions, the weather conditions, the wind conditions of the environment so that you know when it is safe to proceed with construction. Again, vibration information, heat index data of the site in real time, modeled and visualized in a BIM view, wrapped up in a GIS environment. And then another example from Pomerleau. In this case, the utility data came as IFC. The site model itself was, I believe, in this case, a combination of BIM and CAD formats. And here what you're able to see is the water tables, which is GIS data, visualized in the BIM environment to help the planners know whether or not they could proceed with construction. And actually what they ended up doing, changing their method of construction so that the water table, which was planned to rise, would not get in the way of the concrete pours. So IFC data in the form of utility and site information, proprietary BIM information and CAD information brought into, again, a GIS view with layers that can be turned on and off in a web browser for the world of the project to understand. And this is one of the most interesting projects that I've come across recently. I'd say my friends from Skanska UK, from the infrastructure group, doing construction design management, construction progress monitoring, and even pre-construction tender phase coordination by using IFC as the lingua franca, as the Rosetta Stone for the project, and getting great results from it. So they've seen 25% time savings during design, construction, and handover, over 150,000 pounds of planned versus actual efficiencies, improved engagement with their entire supply chain by delivering solutions that use IFC to bring in data from various formats into a GIS view, enhancing the experience of the customers themselves, their entire project team, and really improving Skanska's reputation. So a couple of projects that they shared with me. One is a national highways project, multi-billion-dollar project, of which they've got about a 10-mile corridor, 750 million pound budget for this project. That's roughly 25,000 vehicles going through per day. And then the next project is part of HS2, one of the largest infrastructure projects in the world that probably every design, engineering, and construction firm has their fingers on somehow in Europe. It's the largest infrastructure project and possibly really in the world right now from many measures. And it's more than just a project that is, new rail and new ways of transporting people. It's having significant social impact for the country, bringing people from remote areas to city centers more easily and allowing people to not necessarily just live in city centers, but to stretch out across the country. And in this project, openBIM is core. Their interoperability workflows, they start out with the idea of a common data environment or a connected data environment made up of various repositories, fed from Civil 3D, fed from Bentley AESO Sim, visualized with Navisworks, Revit content, all brought in. But everything then gets converted to IFC, in this case 2x3. They QA the model, they QA the geometry, they QA the semantics and the properties, but from this point forward, everything that they visualize, analyze, report on is using IFC. So they've got third-party systems for QA. The IFC then comes into a GIS. We consume that IFC data directly. It gets integrated through ArcGIS Pro. Some of it is an ETL workflow, some of it is real-time data, and it results in this collaborative, this sharing environment that is based on Esri Tech. So for construction design management, this is really interesting, I think. They perform a process of construction design management whereby they're collecting existing conditions, reporting on potential risks, potential issues that didn't come out in the initial design documents, so that as they start construction and work through this process of understanding the site, construction can occur most effectively. So it starts out with the design team raising a CDM hazard in a GIS view. That hazard gets reviewed by the designers and the contractors. The construction team is then aware of it, so that as they start their process, they can then address the issue before they start construction. So the way they've gone about addressing this workflow with technology is they've built out a solution for this rather complex interchange, a mobile device that uses Survey123, an Esri product, a completely customizable, no code, zero code form application that they capture the conditions, then visualize them on a desktop in a browser-like view. This is using another low-code tool called Experience Builder, where they can zero in on any of those conditions that were identified, view them with more context, see all the properties that were collected out in the field, understand the situation before they start construction. And what they've been able to do is catalog all of the situations that they need to be aware of so that construction safety can be considered more easily. And you'll see that what started out with a rather large number of conditions that they needed to consider at the beginning were addressed and reduced, and actually the schedule estimated to be 25 months was brought down to 17 months. Another example of using GIS and openBIM for construction is progress monitoring. So here we'll zoom in on an element, I believe, of the HS2 project, a particular interchange where the pile driving for the raised bridge of this particular environment, all the model environment was brought in. Again, this is an Esri ArcGIS Online view. All of those piles have 3D visualized content, but they also have properties that you need to consider. And what we're looking at here is a 2D view of that environment, and then a Gantt-like, simple Gantt-like view down at the lower right. And this isn't just a view of the planned schedule. This is actually information that's collected in the field with handheld mobile devices, Survey123 again, to collect the conditions of the piles as they were being drilled in, as they were being reviewed and inspected, and as they were being ready for the next phase of construction. So again, IFC files brought in to a GIS view for construction progress monitoring so that the team understood where they were at any time without needing to be an expert in Oracle P6 or open up any kind of complex BIM application, or for that matter, a GIS application. This is a browser-based application bringing together the BIM and the GIS data. And then finally, pre-construction coordination. When I met with Skanska, they told me that they were using IFC information and GIS to be better, more efficient, more accurate in pre-con, in even bidding and tendering. I was kind of caught off guard. I really didn't think that there could be a workflow that would apply. This is a project more on the eastern edge of London. Again, IFC-based BIM data brought into GIS. And in this case, this was the initial design information that they received. They brought it into GIS to understand the project. They brought it into an Esri environment to be able to analyze and quantify it. And it started out with a very simple 2 lanes each way overpass on this particular road project. They received a second phase of tender documents in the middle of the tender phase. They still had the same deadline to deliver their bid, but using ArcGIS, using IFC data, they understood these changes in the design, which allowed them to be better informed that the overpass size was changing, the gantry signs were changing, and various other elements of the design in real time. They were able to understand this, update their bid, update their estimate, update their schedule. They ended up winning the project, and they're actually in the final stages of construction planning. So just to wrap up, GIS and openBIM as a solution for construction management. When I joined Esri about 3 years ago, I figured I was going to be talking about maps for design and engineering and context helping make better design decisions. I really didn't think that construction management was going to be an area that I'd see so many examples. And these were just a few of them. We have many, many more. And it's not just doing it for the sake of pretty pictures. There's real value here. And this is from Skanska, who is a quite conservative company when it comes to making statements about time that they're saving, money that they're saving, being more effective. But I think it's worth staying on this slide for a second if I can. We'll stay there here. I'm wrapping up here. My timer is at 0. A few ways to reach us. The QR code will let you reach out to us, answer a couple of questions, and we'll follow up with you. Esri.com and aecinfo@esri.com drops into mine and a handful of other inboxes. So for more information, please hit the QR code or contact us. Thank you.
Thank you. Thank you very much, Marc. Very compelling case studies of openBIM and GIS, so data at scale. Our next presenter is Francois Valois, VP Civil Infrastructure for Bentley. Thank you, Francois.
Thanks a lot, Eric. Can you hear me in the back? Hi, how's everyone? Doing good? You guys are asleep or something? So, bonjour, merci. Thanks for having me.
Hello,
at
thank
the
you.
buildingSMART conference.
I'm
going to start with a question. Are digital twin the future of infrastructure, and specifically transportation infrastructure? This is what Bentley does. We're a leading software provider in the transportation industry and others, but mostly focus on heavy civil as well. I'm leading the R&D for Bentley Systems on the civil engineering side of things. So all the products that you guys use that work very well, you can credit my team. Anything that doesn't work, you blame me. Essentially, that's the deal. So let me start with a story. It is 1992. Imagine I have long hair like here, and I wear, Slayers T-shirts, and I live in a small town called Rimouski, which is a picture of that place. And I'm like, well, I gotta go do something with my life, so I cut my hair. So the rock band I'm in kicked me out. They say you cannot be a bassman with short hair. That doesn't work. So I'm just out of that. So I gotta find a job. Because my parents are fairly humble. We come from a fairly humble family. And I go to a restaurant called A&W. So if you're from the Quebec province, that is very familiar. But if you're from the US, like a McDonald's or something like that. And I meet the assistant manager, right? Imagine the guy is 4 foot and something, and a little bit fat with a big beard and something. And then you could see him, right? A typical assistant manager in A&W, something. No offense. And I asked, can I work? I just want to work, anything. I could clean, I could cook, whatever. I have no experience, right? I'm 16. And I just cut my hair off. So I'm like, I hope I can get a job, because otherwise I'm invested a lot in not being part of a rock band to do that. And he said no. And I'm like, holy cow. All right. So go back home, try restaurant number 2, try different places. Doesn't work. 1992, right? Generation X, right? I'm 46. And very hard to find a job at that time. Nearly impossible, actually. So what I did, I persisted, and I went back 5 times to see that assistant manager at this A&W. And the 5th time, he said, okay, I'm going to give you a job, but leave me alone, please, right? And since then, essentially, I've been working really hard in all kinds of things just to advance and be on this stage today. So thanks for having me. So why am I talking about that, right? This long winding story. Because things have changed, this year and for the past few years. We're in the middle of this labor shortage, right? There is a huge amount of retirement. There's not enough graduate, and there's increasing demand for graduate and people. So retirement, some DOTs, for example, MoDOT has basically told us they will lose 20% of their workforce. 20%. That's a huge amount of people, right? Pension program are essentially intersecting, and it's causing a lot of issues on the budget as well, right? There's more people retiring than people coming in. And this is global, right? This is Canada, this is US. Australia is short of 6,000 civil engineers. 6,000 civil engineers. It's crazy, right? So civil engineering schools also are not producing enough graduate, but also they're producing graduate that are not adapted to the world. There is no digital, or data knowledge being injected in those kids. They don't know about digital twins or BIM, that sort of stuff, right? They produce plans, and so that's really hard. And plus those people that used to be, working on different projects, now they have to use complex tools and create BIMs and all that stuff, right? So we need to work on that. And there's increasing demand, right? The recent, amount of investment that we've seen around the world on infrastructure to sort of boost the economy is now creating a huge pressure on all these engineers that need to produce the work. So how do we improve capacity? Well, improve capacity can only come through innovation. Digital delivery is one of these innovations. All right, we've heard, earlier George Lukes and others talking about their journey to digital twins and so on, right? So most transportation agencies are trying to build a plan around that. So it's very, very common. But like any innovations, you have three pillars that you have to build upon, right? People, process, and technology. Otherwise, you're done, right? If you just get one of these wrong, you're finished, essentially. That's the whole idea. So, and this is the same thing for digital delivery. Same thing for digital delivery. Nothing different there. So let's start about people. First thing we have to do is make sure that everybody that can work can work. Everybody in the community has to be engaged. And this is why the current AASHTO president, Dr. Sean Wilson, essentially is wanting to produce and foster a culture of that includes everybody in this, right? Just everyone. You also need to support the kids. So Bentley, for example, is giving money to STEM programs. So every employee has a little bit of money that they can give to local schools and so on. But we pull this together and we make, we build sort of $10,000 and we give it to a school that is going to teach math, science, engineering, and mathematics. That's key. Hopefully you all do that as well in your own capacity. We also support programs like the AASHTO Track and Ride, which is a program that can encourage kids to use digital technology to do all kinds of things. So this is very key. Hopefully you can jump in that as well to help Bentley, HDR, Headlight, HNTB, Michael Baker, Topo, and WSP be part of that. Bring the kids, right, to love infrastructure. We have a Bentley education program where we provide our software for free for all universities and teachers and students as well in that context. Very important. And for working professionals, we created a program called the Premier Scholar Program, which is essentially a case study-based methodology that come from the best school of teaching by doing, teaching by collaborating. And people that come out of that program are essentially the best of the best in using our products, but they also connect with other people in this community of people around that. So it's all about people. The next thing is about process. We need new business model innovations, right? We had the design build coming in this world, and that has helped innovation quite a bit. But we need more of these sort of innovations, right? We need to mandates. We need to do all kinds of things to make sure that we can get there. We need rules and regulation to change. We need the owner to tell us, me, as the R&D lead of Bentley Systems, what is it that we need to implement? right? There's the details of what you need to implement. But also the ECs, right? The HNTBs and all of it to basically be told, there's what you need to deliver. Still today is, very fuzzy, and there's a lot of optionality, which options are good, but also makes it really hard to implement. So if you want to speed up, standardize, it's really good, useful. And finally, technology, and this is where I'm going to spend most of the time today. So digital twin is all about data, right? You heard that a million times. But so these people that we need to train essentially have to come together and say, okay, I'm going to bring it all together in this central repository called digital twin, and we need all of that to come together, but it's all about data itself. So when you build any projects, there's a physical world. You build a road, you build a bridge, you build a building, anything like that. And our pledge essentially to you is to say, you at the same time have to build the digital asset, in the computer, so you can make use of this. So in a world where digital twin is not used, you have all these silos where you have the maps, the reality models, the reality capture, the terrain, the 3D models, the analytical models, the failure modes, all of that sort of isolated, right? What you want to do is bring all of it together and have an evergreen, living, view of the world, the digital twin. And why you want to do that? For multiple things, right? So if you look at the bottom right, you'll be able to do conceptual design, site survey, reality modeling to really advance your conceptual planning. If you go up right, essentially you'll be in the design engineering space where you've been able to do your detailed design, your drawing production, your open digital delivery, and so on, and collaborate and do the design review on that front. And then if you go bottom left, you'll be able to take that data into construction, do your mobile file management, and get those people to get all the data in the field, plan your project, and so on and so on. Do your costing, your bidding, your IoT sensors connection, and so on. And in operation and maintenance, you'll have your asset management, your inspection, condition monitoring, and so on. So here's an example here of a plan, all right, done in our transportation planning products that essentially is allowing transportation planning agencies to create a 5-year plan for a city and to animate that in full 3D around the digital twin itself to be able to see where the issues really are on this. And this is considering traffic studies, real-time sensing, sensors coming directly from the field, and all of that together so that you can determine where is best to build that road, that bridge, that railway, that train station, all of that. You got to do this. And multimodal as well, including not only the vehicle and that sort of thing, but people and that sort of stuff. The next thing you'll do with that information, if you use a digital twin workflows, essentially take all it into tools like this tool here that allows ideation and concepts to be done super easily. We're sort of being gamifying the whole civil design in that context. So we take these very simple concepts, and in this case, we're competing with a napkin, right? So a lot of people use a napkin to jug idea on the things. We're saying use a product like that and very easily do that. Create your animations, bring in there your traffic studies, and really understand what's going on. And then take all that information from concept and load that into your detailed design tools, right? And then from there, you add a lot of details. In this case, you build that complex intersection, and you create these complex parametric models and so on. And that's going to give you essentially the detailed design that will be something that can be constructed. So you're all model-based in that context. But unfortunately, the world is not all model-based, so you got to produce plans. So in these tools, we basically injected the ability to create plans directly off of the model very easily, and all of that sort of keep updated and together all the time. And that's very useful, right? What's going to happen with the annotations if the things are changing? So we keep track of all of this and together and make it consistent across the board in there as well. So all of that is very seamless. So not only do we allow to create very geometrically rich models, this is what the civil engineers have been traditionally doing, we make these models intelligent as well. And all of that sort of semi-automatically or even automatically. And you can take that data and use it for design reviews in these tools. And not only these tools that we have for design reviews are great, and some of these things have been shown here, but they've been designed for civil engineers by civil engineers. And they essentially understand these basic concepts like, like profile, alignments, all these things that are very important for civil engineers. So we're specialized in that side of things. We're not general, we're just specialized in that context. And so those models that are produced are not only geometrically rich, but also data rich. And if you come from the BIM world or building world, that's something common. But in civil, it's fairly recent that we've been doing all of that, and it's being demanded more and more. And then from there, of course, you can take it to IFC. And in 2019, Bentley has basically, been looking at this some more, because AASHTO has decided to make it the construction and roads data exchange standard, right? And we work with almost all DOTs in the US and almost all transportation ministry in Canada and around the world. And essentially, we needed to do something. So we became an international member of buildingSMART at that time. We now have certified professional. We have somebody in my team that essentially is one of the 28 IFC certified professional in the civil side of things in the US. It's not many, right? So we got to make that more. We're an active member of the implementer forum for IFC 4.3. Not only do we wait for it to be completed, but we get engaged. We explain, what we need. We explain civil, we explain rail, we explain road, we explain bridge to those people in there, and we work with this. We did a lot of thought leadership. I was at the Florida user group of Bentley last week in Florida, right? Orlando. There was a room about that size, 350 people or so. And I asked people, how many of you know IFC? Right? 2 people knew it. Right? So it's very new. There's a lot of more advocacy and thought leadership that we all have to do as experts in that field. And we wrote in our DOT newsletters, we also explained what IFC was and what it is and how we explain it to the world. We spotted the TRB Research Board, Transportation Research Board, and AASHTO Standard Committee as well to help on that front. We have not only done and been talking about it, but we've actually implemented within our desktop the ability to import and export IFC 2x and 4x, 4.3 right now, including alignment, spatial containment, semantics, and all of these complex things, right? Just don't, it's very important that you look at the details in some of these things. Not every IFC file is the same. And then we also did it in our cloud solution. So cloud solution allowing to, do that in batch and be sort of essentially delivering, right, at 15%, 30% project, 60% project, and make that data more industrialized and share easily. Let me show you something that is not yet commercially available. It's an early adopter, so there's a little disclaimer right there. When I said we specialize in civil, this is super elevation analysis. And if you're a civil engineer, like I know what that is. If you're not, well, it is when you drive a road, the road does that, so you don't basically eject out, right? And that's what is sort of important, right? And then so we've built a checker of super elevation on any data. So we import, for example, in an IFC model, we can analyze whether the super elevation is right. And we do it on our own data as well. So very powerful stuff. You go to construction, right? We have construction management tool, project management, field solution as well. And this is a 4D essentially animations of a digital twin of what is going to be there, right? And to be able to analyze the potential issues of what might become, So very powerful capability there in the Bentley products. We've been a leader as well on the reality modeling side, the ability to fly drones and convert that data into real models, right? It's very important, right? We don't always have a 3D models. But not only do we do that, but we also been able to extract and inspect that stuff virtually, right? So be able to analyze cracks on the bridge, for example, all of this using that imagery there. So very powerful based on AI and machine learning, we've been able to do that. And then, to me, the top of the pyramid essentially is IoT, right? IoT would be when every bridge, every road, every slope along the road will essentially have some type of sensors allowing people back in the office to determine whether the infrastructure is in the right state or not. And we've made advancement on that as well. We've purchased 3 IoT companies that we've now integrated in our platform. Right? Very important to get all that sensor information in there. So finally, digital twin is very promising. So to answer the question, I hope it's clear that I think, and a lot of people think, that digital twin is the future of infrastructure. It is the future of infrastructure. But for it to succeed, you'll need people, process, technology to all come together. You'll need Esri, Autodesk, Trimble, name it, all open source, and all of this stuff to come together and all sort of, and play together. So at Bentley, we dream very big for the world of infrastructure and transportation there. And we can achieve it together. So thank you very much. Thank you for your time. And come see me around. Thank you.
Merci beaucoup, François. So very inspiring, seeing where the technology is headed. So we'll switch gears a bit. Je vais m'adresser en français à la foule parce que on va pas, dans le fond,
because in 2019, under buildingSMART France, with the BIM group from Quebec and with the CRTB and the Benelux chapter and the Swiss chapter, we created the Francophone platform in order to be able to communicate in our language together and have access to international experts. Ever since 2019, there's been some meetings. We wanted to take the opportunity for this committee in France, in Montreal, to bring a French committee that is here in order to share their experiences on their projects. And we know that within the Francophone world, we still have those same challenges and the same jobs as well. There are elements that are developing themselves within the chapter. I want to link what we heard in terms of the twin technology and the numerical twin to come back to the base. So the presentations will be in English. So I wanted to introduce the French chapter in French.
Around openBIM. And so we invited some speakers today. We have speakers tomorrow that are from this forum. And as I was saying, the link with the digital twin and enabling a digital twin ecosystem is really moving towards a common terminology, standardized terms, words, definitions, and standardized processes. So I'll start by inviting, we'll have 3 presentations, 2 that are in person and 1 online, and we'll go one after the other. So I'll start by inviting Yannick Cotherel, who's BIM Development Manager at Cercal Qualité Certification. Merci Yannick.
I'm actually BIM leader for Cercal Qualité Certification, which is a certification body here in France for housing quality. And I'm also vice chair of the French chapter of buildingSMART, and I'm leading the technical community of this chapter. Today I want to introduce you in few minutes, actually, one important thing about the use of data, the use of data models. And I will define that, like we probably know already, but as a common language. But to use common language and to collaborate with this common language, of course, you have to use a common grammar. Okay, this is a structure of your language. And you have to use terminology to give sense of your sentence, to give sense of your communication, of your exchange. And I want to focus my intervention, my presentation about this particular topic, about semantics and terminology, of course, regarding BIM and openBIM. In openBIM, the grammar is the IFC, okay? This is the structure of your model, your communication. In France, we are working for years now in this particular topic. First, we had a working group dealing with classification systems, because classification system is a method to deal with terminology. We also have and had working groups dealing with how to set a data template, and both of those groups had conclusions that we need to use data dictionaries to organize the terminology and the semantics used in data model. Okay. For now, on projects, at least in France, but I'm assuming it's quite the same anywhere else. We can make some specific space and object nomenclature to define the terminology used. We can use actually on models. We have also different classification systems. Just for the example, in France, we think, do we have to develop a new classification system for BIM and openBIM? We already have the international classification systems used on project, and we decide to not do that because classification systems, and it's really the conclusion of our report. It's available in English, actually, if you want to download it, it's possible, and in French. And the conclusion is classification systems are not flexible enough to cover all of the point of view to define the terminology used by all of the actors and stakeholders of a project. So if you want to exchange data from an architect, an engineer to another users on project, even in the use in digital twin, of course, you have to share your terminology, and you have to be sure that the terms you use to describe your data model will be understood the same way by the other users as your own understanding, okay? On project, you have also object library, product catalogs, and sometimes you can find what I called level of information needed matrix. You know, it's a big Excel sheet with a lot of information on it to define every information needed in each phase. And it's quite a very complicated thing to use, but sometimes you can find it on product. Dealing with data dictionary, what it is important to understand, it is on data dictionary, we are defining properties, okay? Properties, it is the content of a model, okay? Properties are group of properties, and all of this content from that dictionary can be used to define data template, and data template can be used after that to define object library or product catalogs. It could be used also to define your properties on your model on project. But there is a very specific structuration of the information to ensure that you are able to define your project, your model, your object using one reference host in a dictionary. What is important to understand, I want to repeat that. On project, you don't have one semantic, you don't have one terminology used, you have a lot of terminology. Sometimes you have different languages, but you can have a terminology from the regulations for energy, you can have a terminology from the standards for engineering, and it is the same for other users. And what we want to achieve with data dictionary, it is the ability to link those terminologies or semantics together to create relations between terminology, and also to link those source of semantics with the IFC to create a complete interoperability between softwares or between actors. In buildingSMART, at the international level, we have data dictionary. We have the BSDD, the buildingSMART data dictionary. It's not new, because the first release of this dictionary was published in April 2008. But as a users, because I'm more users as a technical guy for this topic, we miss some tools to be able to manage the content of data dictionary, because it is important as a users, when I will collect, when I will use a specific definition of a properties of a term housed in a dictionary, I want to use who did it, what organization defined these particular terms, and I want to have trust in these terms to be able to use it on my project, and probably why not to define a contract based on these particular terms. Okay, so we have some ISO standards allow us to set a proper governance on data dictionary. Just a few words, because we have solution to do that. As a chapter, though we are not software vendors, but as a chapter, we decide to develop a specific tool, an open tool for the whole community, actually, to be able to set governance on data dictionary. This tool is called Semantics for BIM. If I put the purpose of the tool in the pictures that I showed you previously, we want to allow people and organizations to set properties, data dictionaries, or properties and group of properties, and data templates. All right. I want to pass that. There is a website if you want to know more about this tool and how to use it. Actually, if you want to know more about data dictionary and how it can be useful for you on your projects and for your objectives, do not hesitate to contact us. Do not hesitate to contact buildingSMART in general, but I'm available. We have a specific website for our tool, and I will be more than happy to answer your question. So do not hesitate to contact me. Thank you.
Merci, merci Yannick. Merci beaucoup.
Thank you very much. Thank you, Yannick. It's very appreciated.
Our next presenter, so the language, the semantics, the how do we understand each other, and how do we connect them and build those into processes? So Alar Jost, who's vice chair of buildingSMART Switzerland, will come and talk to us about the use case management tool. Thank you, Alar.
Thank you so much, Eric. So, and thank you particularly to the Canadian chapter for having us, and the Forum Francophone, even though I'm a very bad representative of Switzerland as I don't speak French. But I can refer very well to some of my speakers, particularly to starting jobs 16 years old. I think my key qualification is still being a car mechanic and having had 3 different placements for my apprenticeship over 3 years. So, but I think what still keeps me going and is really relevant until today, and what refers to the last one of my hats here that I'm bringing in, is that I'm still engaging in projects and getting my hands dirty. So besides my day work or night work, one never really knows, so of being a representative for large owner institutions like the airport in Zurich, I'm bringing you something today with my other roles as co-lead of the use case management. And referring to the speakers, or with the use case management, and as it was presented by Richard Kelly as well on the Open Plenary, we have here a platform, a service that really connects many of these aspects, as Yannick has presented them, on how to actually make use of the standards in the openBIM context that we have in buildingSMART, and how those actual standards can be and technologies can be applied and brought or can be brought together into the projects in a way that particularly owner organizations or anyone that needs to order information can actually get started and put them together in a way that they can be used in the project. So what we have here, and you see it in this kind of outline of the ecosystem of services that we have here in buildingSMART. Of course, we have the data dictionary as just presented by Yannick, or that provides essential structures for the entities that we want to use in the projects. And we have, for example, exchange possibilities with the BCF, or particularly with the IDS, or where we can then transport information throughout the projects, but we need to start somewhere. And if we look into the technical roadmap, or if you look at this round trip of actually ordering information and managing information, at the very beginning there is a use case, because for whatever we have, and we saw it in the amazing samples of actually best practice projects from Esri or from the other presenters, or that all in those projects, whatever we see there, whether it's a road or rail or construction or maintenance or operations, there is always a certain use case behind that brings the reason why we do something. And this use case, if we want to kind of move on from an analog human understanding of managing information into actually digital machine readable understanding of information, or this use case needs to be transported into a digital readable way. And we, within the buildingSMART International environment, or we have created the use case management service, which is actually a service that brings together the three key components that you need to actually build a use case or define a use case, and then that you can actually bring it into the project. So what we have there, and when I refer to the use case management as a service, it's really like a platform, which is a co-creation space where you can bring people together and arrange or let's say, not arrange, but you can actually bring people together to define your demands, to have a structured way of bringing in all your definitions, your roles. You can access structure via the BSDD or other classifications. You can define your processes, and you can define your exchange requirements. So with this bundle, as well known as IDM, you have actually defined what you want to do. And then from there, you can export it via the IDS, or you can actually give it into the process, into the round trip to get started, to have the information used in the projects for the delivery. And just as one example of many possibilities, so we see here reinforcement definition, or so people have got together and defined the process. Okay, how do we actually automate the production of reinforcement in the project? Or they have defined their exchange requirements, they have defined their roles, their processes, and the exchange requirements that are needed in the project. And from this point, or it can be given out, it can be ordered, it can be part of exchange information requirements, definitions for projects, and all the later use in the authoring systems, the modeling, the construction can run alongside these requirements, and as well the whole checking can run alongside this. And if you take this any further and go, for example, for the operations and maintenance perspective, of course you can as well define the order of maintenance relevant information in the projects. You can run all the checking processes that you need and can take it further. So if you by any chance go to that QR code, to that link, or you will come to the platform and you will see the environment that is actually set up as a content management system where you as an organization or individuals can come together and define and work on use cases that then can be handed over and given out in a structured way. So what's the, coming back to why is this relevant, particularly for maybe larger or state organizations, or it's all based on the relevant standards. It's all foremost on the IDM standard, which has the processes and the roles and the exchange information definitions, but as well, of course, it's following the ISO 9650 kind of round trip standards and everything else that is related to this, which is already like embedded in the platform, into the use case management system, into the CMS, that whatever you define kind of follows those standards. So kind of bringing together, and once you have created your use case, you can bring it to the market, you can actually have it consistent, continuously used via the IDS that is transporting the exchange requirements, and it can actually activate it in your way in the project. So, and not to confuse you with too many details, but just to say, like, if you are interested in getting more to know more about this, I will be more tomorrow in the Gen 6 at 11 o'clock and giving a much more detailed introduction. So thank you very much for being part of the Forum Francophone in an extended perspective, and maybe linking a little bit what is needed to prepare if you want to get to your digital twin, or that if you want to have a digital twin in the end, you have to order it, and to be able to order it, you have to define what you want to order, and that's really where the use case management comes in, because it's the platform where you can handle all those aspects in a structured, in a defined way, following the relevant standards that are available. So thank you so much, Eric, for having us.
Thank you, Alar. Merci. Thank you very much. And for the final presentation, we're going online. So we were out west, and now we're going east to, well, not too far east, to Belgium, to meet Charlie Boon, who's from CRTIB. And I'm hoping he'll pop up on the screen. It's late. It's 11 o'clock there. And if we can't reach him,
good afternoon, everyone. I will talk about exchange information requirement, level of information need, and IDS. So CRTIB is the Luxembourgish construction platform. It has been created by the Ministère de la Mobilité et des Travaux Publics, the Order of Architect and Engineer, and the Chamber and the Federation of the Builders. We work with consensus to generate some works that are accepted by all stakeholders in the construction. Okay, so you can go on with the presentation. Thank you. We one more. You can click the next. Yeah, we work on several topics. Yeah, we are working, our work is based in working group, BIM working group by topics, like we have a certification, training, authorization, technique and softwares, and so on. Yeah, next slide, please. Yeah, I'm really sorry because it's not very synchro. Next slide. So we have created some national EIR. We didn't want the level of development because it was not accurate enough. So the national EIR are split into requirement for geometry, information, and documentation. We also split the requirement by phase, 5 standard phase in Luxembourg, and also by object, so one sheet by object. But there is no use cases. It's just a standard project, and we didn't split the requirement by discipline. This principle of splitting GID requirement are included in the EN 17412/1/2020 because we were part of the development of this EN. So we can pass to next slide. Okay, the last year, in 2020, we've seen that we had some, many modelers had some problems with the exchange. in openBIM, several reasons. Some error from the modelers, but also some problem in the implementation of IFC in modeling software, and even if IFC viewer. So the idea was to help them to make some automation, and for that we have created some IDS, so information delivery specification. The automation is at 3 levels. First one is to implement the requirement into the modeling software. The next one is the IFC mapping, so from the native software to the IFC file. So each native property is mapped to one property, IFC property, and in the right pset. The third step is the IFC checking, so to make an automatic checking of the whole project in once. To be able to do that, we needed to be more precise at the requirement level. So we use level of information need, which is actually an EIR for a specific context. So we always have the requirement for geometry, information documentation, sheets by object, and splitting the requirement by face. But we had the extra specification for use case. Which use case? So we define a minimum requirement for the traditional use case, and then we say, okay, and we will develop some level of information need for extra use case later. We also made a breakdown about the requirement for stakeholders, not requirement by stakeholders, but at least we split the object from disciplines, so architect, structural engineer, and MEP. Okay, next step, next slide, please. Okay, we have developed 2 tools. First one is the GID browser, and so to access the information about the requirement. And the second is the use of the IDS. So let's have a look at the first one. Oh, one more. Okay, so 4 steps. So it's website digitalbuilding.lu. Guide interopérabilité, for instance, it's only in French, but it's planned to be in English. So you can select the object by keywords, technical stuff. And when you type a keyword, you have all the sheets where this keyword is linked. So you can open this sheet, or you can type an IFC class or a predefined type or user-defined type. And okay, so the next step after that is you arrive on the GID sheet. Here you have the mapping of the each keyword are mapped in IFC 2x3, so IFC class plus type, and for IFC 2x3 and IFC 4. You have also link that send back to the website, the buildingSMART website with the IFC schema 2x3 and 4. Okay, so next step is the requirement themselves. So you have level requirement for geometry, information, and documentation. The requirements are split by face, 5 faces. And you have the mapping for each properties or attributes, so for the information part, into property and pset if it's a properties. So next step is the last part is about the classification mapping. So 2 classifications are used in Luxembourg. We have the DIN 276 and the Uniforma 22010. So for each object, you have the classes that are linked to these pages. And the last thing is a chat that is available for anybody to make their feedback, to ask some question about this object or how they should use it. So we try to collect a structured way of collecting the feedback to be able to improve our standards. Okay, so that was the first tool. The second one is the demo of the IDS use. So IDS, we have IDS for Revit. They are ready for the discipline architecture, structure and MEP. We are developing them for ArchiCAD and Allplan. We work in collaboration with Belgium, the BBRI. We are collaborating for several months now on the developing of the content of the portal and the requirement. And we do that through the Forum Francophone de l'openBIM. Okay, so let's have a look on the demo. So first step is to download the IDS and to set up the software. There are several details about that on the website, so you have a step-by-step guide. But okay, just you set up that. Next step is to fill in the properties. So we can switch to the next slide. Yeah. In here, so for example, we create a database for the classification manager in Revit, where we combine the classification of IFC2X3, IFC4, DIN, and Uniformat 2. So we have a pick list full with every entry that we need. To fill in the properties themselves, we have a plugin over there where you can select the version of the GID sheet, the discipline, and the phase. And after that, you just select one object. You can also use some sub-categorization, and you have pick list of several properties. So that is the easiest way to get the right information at the right place with the right capital letters or not, and the value. If everything is standardized as much as possible, then we get some better IFC at the end, and that was the point. Okay, so next step is to generate the IFC file. Okay, there are a couple of comments, you can skip them and pass to the phase 3. So phase 3 is about the IFC mapping. So there, first of all, you download the MVD, so the translator, and second step. So once you do that once, and the second step is to load the IDS, and you load one by discipline and by phase. So at each time you pass to a new phase in the project, then you switch you load the next IDS file. That's for Revit on the left, and we get the same in ArchiCAD on the right, MVD plus IDS. Okay, so now step 4, it's just the IFC that we get from that. So I did it very quickly, but actually, let's say that the first time you try to implement that in your software, it takes 30 minutes. When you are used to do it, it's less than 10 minutes. And so it's really quick to get something really efficient for the modelers. And that was the idea. So you can launch the video, but it's just the IFC, the opening of the file that was created just before. And we see the properties of the object. Okay, so that's it. What's coming next? First thing is the IDS and the resource, or the step-by-step guide for other software, so ArchiCAD and Allplan. A German and an English version of this guide. And for the English one, we will include the Dutch keyword for friends from north of Belgium. New GID sheet. For the moment, we have around 80 sheets, and we have submitted 60 new sheets to cover as many current objects that is required. So we will decide which sheet will be developed in priority. We are also currently updating the requirement about geometry and documentation to be perfectly compliant with the EN 17412. Because we are at the level of information, but not completely at the level of geometry and documentation. We have also IDS. We would like to develop IDS for the rule checking, automatic rule checking. When you generate your IFC, you can check if everything is right in one operation. If you receive an IFC from somebody else, you can check if this IFC is compliant with the the level of information need. We would like to add some extra use cases, the commonly used in Luxembourg. So we will create some level of information need for each use case and the ideas that to implement this use case into the software too. We would like also to share our IDS template. So it was created on the platform BIMQ from AC3, and the idea is to share this this database with anybody, so people can take the standard, add the specific requirement for one project for one client, and generate new IDS for all the stakeholders of this project. Yeah, and we have also extra ideas about new development, like property description for each one directly included in the software. So when you click on a property into Revit or AutoCAD, you have the description of this property, and especially the information about which regulation is taken to definition, and also some helps about the tool that would be nice to use for each object. So usually you have several tools that you can use for one specific object, and so just listing the pro and the cons, it's not a complete guide of the software. And we are discussing with the reseller of the software to put that in place, because it's not our job. We define what we need in IFC, and but we help people, modelers needs helps to go to the straight and the more efficient way to get that file. So we help them. So that's it for me. Thank you for listening. Sorry for the technical trouble. And yeah, so all our resources are available for free. So you can just go on the website, download the package, and just follow the steps and try that. And please try it and make us some feedback. That would be great. Thank you. Merci.
Merci beaucoup, Charlie. Et désolé,
Well,
je t'ai mis en Belgique, mais tu es au Luxembourg.
I put you in Belgium, but you're in Luxembourg.
Thank you.
Luxembourg.
So thank you to everybody for sticking around. We're 10 minutes over, but really much appreciate you being with us throughout the day. So this is the end of day 2 of the International Summit, end of day 1 of the National Conference. So we'll be here tomorrow morning at 9 to start another day of exciting discussions and conversations. And of course, please feel free to connect and discuss, and we'll see you tomorrow morning. Thank you very much. Merci beaucoup. À demain.